So model examples and sources, there is this really good news out there that for virtual platform, for early software development, for verification, and for architecture exploration, as Zhu from Intel just pointed out, you have this new level of model interoperability, meaning previously proprietary interfaces have been standardized and virtual platforms are now really interoperable. And we talked a little bit about that this morning in the System C user group meeting, that our models really now work in Corvair Simulator and vice versa. So for you as a user, this has become a very nice interoperable situation for the simulation of virtual platforms. And things which make virtual platforms fast, just to mention a couple of them, and those are really the three main ones from a virtual platform perspective, which makes things fast, are the DMI backdoor access into the memory, which is now standardized and is allowing to the uninhibited ISS execution. So you can basically, instead of trickling through the hierarchy of a bus system and accessing the instruction memory leading this back, you have the backdoor access for fast software execution. So that's one item. The other item is the loosely timed modeling, where you basically have those timing declarations and you can do the speed accuracy trade-offs, which the colleague from Intel just described. And then the third item which makes virtual platforms fast in System C is this notion of temporal decoupling, where when I explain this to customers, or trying to explain it to customers, you have gone away now from the Roman battleship drum, which at every drum cycle has every component in the system check in every clock and basically continue by one clock cycle. You have this notion of every participant in the system running freely for a previously agreed upon time, and then synchronize after 400, 500 instructions and so forth. So you have this interoperability, it's all great, but there is a relatively big but, which we admit to as vendors and users of TLM2. You have some choices to make, right? So you have different views which have been previously, that was called programmer's view, TLM, now which is now loosely timed. You have the timed version with the approximate timing. Then you have C-translated models, as you can get them from companies like Carbon. You have co-emulation with the actual hardware, or you co-simulate with the RTL. So you have those mixed approaches here. So you have to really choose which accuracy, speed choice is best for your particular situation, really driven by the use models. So if you want pre-silicon development and integration, an LT view will allow you fast software development. When you want to do architectural exploration and some more timing critical software development, you need to go to the AT level. And then for verification at the end, you need to really verify it against the implementation. And then users, of course, are moving up even beyond that, right? So then on top of it, you have abstraction levels beyond just the loosely timed and the approximately timed, where you basically now start virtualizing away things in your operating system by saying, oh, I have this OpenGL stuff, and now instead of executing it, I'm mapping it natively into the host simulation portion of it, and that's basically the next level up of virtualization. So besides the choices of which accuracy speed combination you need for your particular problem you're trying to solve, you're also facing the issue that each of the styles has several legacy predecessors which need to be connected into the interface as well. So over the 10 years of virtual platforms at Vertio, which then got acquired by Synopsys, we have, as I mentioned, more than 2,000 models internally which really are out there in previous modeling styles.